Right now, somewhere in a laboratory, two particles are born together. Not just created near each other, they become part of the same quantum system. Then scientists separate them, not by inches, not by meters, but by hundreds of kilometers. One particle travels to one laboratory, the other travels somewhere far away. And then something strange happens. Scientists change the state of the first particle, and the second particle reacts instantly, as if it somehow knows what happened. But there is a problem. There is no signal, no message, no possible way for information to travel that fast. Even light itself would not have enough time to cross that distance. And light is the fastest thing in the universe. In 1935, Albert Einstein tried to prove that this could not be real. He believed there had to be something hidden, some unknown mechanism that explained what was happening. He famously called it spooky action at a distance, because it challenged everything we thought we knew about reality. But let's imagine it in a simpler way. Imagine you have two identical socks. One is sent to the other side of the world, the other stays with you. Before you check them, you don't know which one is left and which one is right. They are not simply hiding the answer does not exist yet. The moment you discover that your sock is the right one, the distant sock becomes the left one. Not because a message traveled between them, but because the two were connected in a way that does not follow our normal understanding of distance. This is the strange behavior of quantum entanglement. Entangled particles are not completely separate objects. Instead, they are described by one shared wave function, one system that exists across two different locations. Change one part of this system, and the entire system changes together. For quantum particles, distance does not work the way we expect. This phenomenon is called quantum entanglement. For decades, scientists searched for a hidden explanation. Maybe particles were secretly communicating. Maybe there was some invisible signal we couldn't detect. But in 1964, physicist John Bell created a test to find out. If a hidden signal existed, the mathematics would reveal it. Scientists repeated these experiments again and again. For decades, and every time, the hidden signal explanation failed. In 2022, 3 scientists received the Nobel Prize for experiments proving the reality of quantum entanglement. The particles really do behave differently from anything we experience in everyday life. They remain uncertain until the moment they are measured. And this breaks one of our oldest assumptions about reality. We always believe that things only affect what is directly around them, but at the smallest scale, particles seem to ignore that rule. Space itself may not separate them in the way we imagine. Scientists even tested this across enormous distances. In 2017, researchers used a satellite to send entangled particles to different locations on Earth. The particles showed matching results faster than light could ever carry a message between them. The final loopholes were closed. So what does this mean for us? We usually imagine ourselves as separate points in space, a single person, a single object, a separate piece of the universe. But at the smallest level, that separation may not be so absolute. Every particle in your body has interacted with other particles. And those particles have a history that reaches back through the universe, back through atoms, back through stars, back to the beginning of everything. In a strange way, you are still connected to the universe around you. Not through magic, not through mysticism, but through physics that we can test. You were never as separate as you thought. The universe was connected all along. You just never noticed.